Hello again. I am Giorgio Solubis. This is the second video of the AI referee in sports. At the first video, we showed how we set up all the components, how we picked all the components to help us in defining a very specific task that it is the volleyball block touch system. So basically in this video, we are going to show right now how we are going to connect all the components together. And we are going to download the Pylon software from the Bustler web site, and we are going to power up the camera and just show how you are going to use the Pylon software to have the footage of the camera on your machine. So basically, if you check the first video, everything is going to work on Nvidia Jetson Orin Nano. This is a Linux machine with an ARM processor. So basically, we are going to download the specific software to use it on this module. If you remember, to power the camera, we need a power over Ethernet module. This one, you can plug it on the wall, and then it has two sockets. One socket each for the LAN of the Jetson Nano, and the other one is to power and connect the camera. So basically, let me plug it into the socket, and I will just put here the LAN cables directly. Of the first video, we also showed the camera. The camera has behind like the two ports. One is the LAN that we are going to use the power out of the module that we saw that it's going to power the camera, and the other one is the Hiroshi cable. So you also the Hiroshi cable. Basically, I decided to buy that because in the future probably maybe there is a task that I'm going to use it, so it's a nice opportunity to buy that. It's not very expensive. So basically, this one goes behind the camera, and on the other side, it's like an open cable. You can do it whatever you want. For example, I have connected that with a small I2C that I soldered, and to use it with the 40 pins of the Jetson Nano. For our experiment, we are not going to use the Hiroshi cable, but in the future, if you want to do other experiments, it's nice to have. So basically, after using the power over Ethernet, you just take the cable and you just put it behind the camera, and you just connect it. When you do that, the camera inside has its own clock. So basically, you can use the camera with its own clocking mechanism, and if you want to go to the field and like having the camera like 100 meters away from the from your module, then you just need the LAN cable and the power over Ethernet. You just connect it, and you don't need the Hiroshi cable. So this is basically the LAN cable goes to the power of Ethernet, and on the other side of the LAN, it goes directly to the Jetson Orin Nano. Having that, let's go online. Let me share the screen, and we can see what software we have to download to use the camera directly. So you go to the Bustler website and go to the solutions, and of course to download the software. On the left side, you can select the Pylon, And of course, now we are using a Linux module, so you can select also the Linux. And it has available some versions. I think that I have downloaded one of the latest. You can just click the latest here from May, and you go down there. You can download directly the tar.gz that has inside some files that we are going to see. And this is pretty much the whole thing that you have to do. Just click here, just download it, and you go to the download folder and you see the file here. You unzip it, and you have like some README files, and you have the code meter file and the Pylon. So basically, these two are necessary, both. And after some research, the instructions are to just you install first the code meter, and then the Pylon, dev file. So that way you will have not a lot of issues, and it will be installed perfectly inside your module. And then you can just open the terminal. First, you can let us the command for the code meter. You can do directly sudo dpkg and install the code meter, and then you can do the same for the Pylon file, or whatever you name it, you just put it there. When this ends, probably some programs, some modules, they have been installed in your module that they are needed from the software. So basically, it's good after this, and you see some errors, it's good to do sudo install F. By doing this, Linux is downloaded whatever is missing from the dependencies of the Pylon. And when this ends and downloads whatever is missing, then it goes back automatically and install the rest of the Pylon program with no errors. So basically, after doing this, these just 3 commands, you have everything in your module. If you go down at the programs that you can see here at the Linux, then you can see the Pylon IP configurator, and of course you will see the Pylon Viewer. This is what you need to run at the bustler camera, and you check immediately that everything is working fine. If you open the IP configurator or the Pylon Viewer, probably you will see some issues that the Linux cannot see the camera, right? You have to do some configurations on the settings. So the Linux can see the bustler camera and the drivers, and everything works okay. So it can have the footage inside the module. So basically, you can open the wired settings, and one of the things that you have to do is like open the settings there and check some of the details here. So basically, you can see at the identity, one of the things that you have to do is like change the MTU, that stands for maximum transition unit, and make it like 9,000, because we are going to shoot at very high frames per second, so it will be like more than 200 frames per second. And so the packets of the data that they are going to come inside the module, they need to be packed together, and this setting is called like a jumbo frames. So basically we have more frames and a bigger amount of packets going into the module, so the CPU work in less to handle all these packets coming in from the camera, because the amount of data that will come, imagine like 200 frames per second, so the image will be probably like 700 kilobytes. So this will be really intensive for the CPU to constantly work and I take all these packets of the data. If you leave this setting like 1.5 thousand, that is the default for the Linux. So it's better to make it 9,000, and you will have a flawless system, and you will not miss a frame from the footage. You can check also the IPv4. This one has to be selected, at least on my module. This works perfectly. It's the default setting, so you can check it that it is. If you want, you can just use a manual IP here and use your own, but this one is, this works perfectly. After that, one of the things that I had issues was the firewall of the Linux system. So basically, if you cannot open the camera and you cannot see the footage, then you can do sudo qfw disable. So basically, you disable the firewall. So you can disable the setting and you can have the footage of the camera because the firewall is default enabled on Linux. So by disabling it, you can be sure that everything is working perfectly on the Linux module. I think that we don't have something else. This is what is the minimum that you have to do to install all the software on the Linux module. And then you just click on the Pylon Viewer to open this, to open the program. When you open it, it just is browsing the camera. You can find it here on the devices. You just double click here and you have the camera, you have the footage here and all these settings. Sometimes it is not opening by default. You don't see something. So probably it is better that you click one of these and you have the footage of the image. You can just zoom out to see exactly what the footage will be inside your home, for example. You see a couch and etc. Let's put this aside. Yeah, and this is the footage of the camera. By doing this, disabling the firewall, making the MTU 9000 to the 9000 settings, then you have this footage, and you will be sure that the camera is working fine. So basically, when you power down the camera and power it up again, then some settings, it's like going back to the default. You see here that it's working at 50 frames per second. You have to experiment here with the settings, or we can check that in our next video to see how we are going to change the settings and using the one more small Python script inside VS Code, and then by the time that you power on the camera, you just run a small script, and then the settings that you have said before, let's say that you were working with 200 frames per second, then it's immediately available for the camera. If you check at the options here, you can go to the camera. Let's say that we want to, let's say, stop here, and this is okay. So basically, you can save the settings inside the Pylon Viewer. You can do it programmatically, but for the first time, it's better to save these features to the Pylon feature stream file. When we save that, then the system goes and save all the settings inside. Let's open this file to see what is inside and what settings. It's like numerous settings inside this file. So I have saved one that I'm using for the experiments. You can see here that it has some characteristics of the camera, some IDs of the camera. You can see that it is setting the gain. If you prefer, it's called the ISO. So basically, if you want to shoot at 5 frames per second and you want to get all the information from the camera, it's better to have this 0, better to have good light and make the gain 0. You can change the black level. You can experiment with a lot of settings, and you can go and read about these on the camera manual. Of course, it has the gamma, which helps a lot with the shadows and the light, because when the sensor is getting the photons, it's like the more the photons, the more the electricity that comes inside the pixel. But the thing is that the humans does not perceive the same way, because we have a lot of sensitivity over the shadow. So basically, the gamma is helping making the contrast better. It's one of the settings that's really, really helpful. You can see the width and the height of the footage. And of course, if you just set it and you don't set the offset, then you will get the top left crop region of interest of the camera. But you have to set also the offset here and offset X and the Y, because if you want to get the region of interest of a different position inside the footage. One other really interesting feature is the exposure time. This is really cool. Yes, because if you want to go with 200 and more frames per second, this has to be like 3,000 microseconds. It means like 3 milliseconds. So imagine the shutter is open like for 3 milliseconds. And that's why we need to have the setup we talked about at the first video, with a specific lens that has a specific aperture. So at this small amount of time, you have a lot of light coming in, getting a really good image. And after saving all of these settings, then you have this pfs.pfs file that you can use inside VS Code, load it, and then directly you have the settings that you want, and you can continue your experiments. So basically, that was all about the second video. We talked how to connect the camera with the power over Ethernet, how to connect it to the Jetson Orin Nano. The camera is set up with a specific lens on top of the sensor, so we can get the footage. We saw how to work with the wired settings and how you can change the maximum transition unit packets. Instead of 1500, you can go to 900, so it's better for the CPU. And how to disable the firewall, and then how to open the Pylon software after you have installed it, so we can have the footage. And of course, if you change the settings, then you will see here at the acquisition controls, it has a lot of settings inside. One of these is the frames, so you can make it like 200. You can just stop it, and then you can start again, and then you will see the camera is working with more images per second after you save that to the PFS file. Yeah, that's it. Thanks for watching, and like, comment on the channel, and talk to you on the next video, where we are going to see how we are going to use the camera inside VS Code, and how our first video shooted at 200 frames per second. Bye bye for now.